Good morning all, it's Postbag, and today we have adapter, no description, and kit 850490. And my Postbag videos are supported by my 104 patrons who support me via Patreon. So massive thanks to all 104 of you who support the Postbag videos via Patreon. I will put a link to this Patreon page in the description below. So let's start with adapter, and this one is from Sunhua. So let's see what's in here. Well, adapter, it would appear, is actually microphone. Karaoke style microphone. Wow, it's big, isn't it? Which is, Kongin. It's actually a wired. There's an XLR plug here, so that plugs into the bottom there. Or wireless. There's a receiver here. There must be an antenna somewhere. Where's that? Yeah, here's the antenna, which has a sort of pseudo XLR type connector on it, so that plugs in there. And then when you use it in wireless mode, you remove that, you put a battery in there. This has got 3 positions on the switch: off, mic, which I presume is wired mode, and on, which presumably brings the battery into play and transmits via this antenna. I can see a few inductors just up inside there, just about see those. So there's some circuitry in there for the transmit part of this thing. But yeah, that's really neat. Wired or wireless, that's the wireless receiver, terminating in a 1/4 inch mono jack, or you can run it through the wired cable. Nice. Let's see what this was on eBay, I believe it was. So yes, this was eBay. It's Karaoke Singing DJ Professional handheld wireless cordless or wired microphone mic. $12.99, that's about £9.14. There is $1 of shipping as well, and that came from Sunhua Digital. The professional wired and wireless microphony of good quality will bring you into a world where you can sing happily and freely to your heart's content. I might do that on a video. Well, now interestingly, it says frequency range is FM. So is it an FM transmitter? I was assuming this would probably be 2.4 gig digital, but maybe it is FM. Actually, I wonder if I could pick that up on an FM receiver. We could try that. Frequency response is 100 Hz to 10 kHz. Signal to noise, unidirectional, takes a 1.5 volt battery. Impedance is 600 ohms. Now the problem is I don't have anything I can plug this microphone into to actually test it, because I've got various amplifiers, but they don't have the mic preamp that would be needed, because the signal level from this will be very, very tiny. With the receiver, of course, that could be boosted, but then maybe this has been set to put out about the same level of signal as the microphone will do on its own without any battery in there. Not sure. Quick test on my little mini active speakers, but of course they're designed for line level, not mic level. Hello, hello, hello. No, nothing there. So let's try it with the wireless. So battery in the microphone and switch it to on. Battery in the receiver, that's on. And I can just about hear that. Hello, 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 hello. I'll just put the speaker near the camera's mic. Hello, hello, hello. Is it that side or is it that side? Hello, hello, hello. But yeah, that's just about coming through. So with a bit more amplification, I think that's going to work fine. Now, this microphone I bought for my vocoder project so that I can sing to... Oh, that's interesting. That's causing problems with the RF. Listen to that. As I scratch the outer surface of the case. But yeah, this is for the vocoder project and other audio projects. I can sing to my heart's content. Wonderful. And yes, it does seem to be on the FM waveband, round about 106 megahertz FM. We're getting feedback and not very good FM connection, wireless connection, and the sound seems really quite distorted. I suppose it's a bit naughty that it's on the public FM waveband, but that's what it seems to be. Okay, next up we have kit 850490, which I think is a Banggood number. Let's see what's in here. And it's a kit of parts. And yes, this did come from Banggood, and it's a DC to DC mini power converter. It's a curious hybrid thing, this, because it's got switch mode. There are three inductors there, 330, 330 and 330. Now where's the main switching chip? Can't see it just for the moment, but it's also got standard regulators, a 78M12, M05, 79M12, which is minus 12 volts, 79M05, and there's a little 1117 3.3 volts. And so you can see here on the outputs we've got 12 volts positive, ground minus 12 volts, plus 5 ground minus 5 volts, and 3.3. And you can put anything from 5 to 24 volts in. That's actually a really broad range, isn't it? So this is just a multi-voltage power supply. 5 to 24 in, well, I can put 12 in from my solar power system and have all these voltages. Finally, I've got a bench power supply. Now, I don't think the current rating of these regulators is particularly high. And in the kit, you get a lot of these stick-on heat sinks, which are probably not terribly efficient because you've got to go through the sticky self-adhesive pad thing before you get to the metal. But let's have a quick look inside this. Actually, first, let's look at this on Banggood.com. This is a DIY USB boost single turn, not sure what that means, dual power module linear regulators, multiple output power kit. It's product ID 1022517. Seems very reasonable value, this, for all those components. $8.44 free shipping. This must be a buck boost topology, because if it can take anything from 5 to 24 on the input, and the outputs are 12, 5 and 3.3, you also got the negative voltages, so that must be the third inductor is producing those. It'd be very interesting to take a look at parts of this circuitry to find out how it produces the positive and negative voltages and what they are prior to being regulated down by these linear regulators. I would have thought the output from this would be reasonably clean, because we've got the switch mode circuitry here, but it's being regulated with linear regulators, which is going to clean the signal up quite significantly, I would have thought. So yes, in the details below, we've got input voltage 5 to 24 volts, output plus 12, minus 12, plus 5, minus 5, plus 3.3. Now it says output current 300 milliamps per channel, which is a bit limiting, but I'm just wondering whether that's a limit of the switch mode regulator, in which case if you're not using some of these outputs, you might possibly be able to draw more. I don't know what the current limit is on the little surface mount linear regulators. Perhaps that's the limiting factor. No circuit diagrams or installation instructions, just glue on all the parts that, solder on all the parts that are supplied in the bag. There is a forum there for assistance if you get stuck. It's going to be fun doing this with my 18-watt soldering iron, isn't it? Now, some people have mentioned that I never actually got around to building this, which is the DDS signal generator, which also came from Banggood. And one of the reasons was because of this rather awkward plus 5, plus 12 and minus 12 requirement for this unit. But of course that's solved by this board, because it provides those voltages and more. So I can also now build this unit. So it does look like there will be a couple of kit builds coming up. Okay, next we have this one. Let's see what it is. It's a light bulb. Of course it's an LED filament bulb. What else would you buy these days? You're mad to buy CFL. You're completely mad to buy incandescent. And this one is 8 watts, because I've got a 4-watt bulb in my lounge and it's just not quite bright enough. Of course there used to be a 100-watt bulb, in the lounge. 4 watts LED filament kind of is a bit like 40 watts. So I'm hoping that this 8 watt LED filament will be a bit like 80 watts. So this is the 4 watt LED filament lamp from the lounge. Of course, it's in a B22 to E27 adapter. And you can see that the 8 watt is quite a bit larger. Has, of course, 8 filaments in it. Should we plug them into a power monitor to see whether these wattages are exact or close? Of course, we used to have a 100 watt incandescent, which gets really hot. It's actually quite a unique thing these days. Hot bulbs. We don't get hot bulbs now with these nice LED filament ones. That's taking 96.2 or 3 or 4 watts. Something like that. So the 4 watt that has been in the lounge for a while and isn't quite bright enough for me to eat my dinner in front of the TV measures 3.6 watts. And the new 8 watt is measuring a little bit low. 6 watts, that's really quite low actually. I'm sure that was measuring 7 just now. But anyway, 6 watts is better than 3.6, so I'm going to put that in the lounge and see whether it's bright enough to eat my TV dinner. You can just about hear the switching circuitry. You can see just down in there the board. I'm not sure if that's focused, but there's a couple of visible surface mount resistors in there. I suppose I shouldn't get too near the metal really, should I? Because this being a B22, I don't know which is live and which is neutral. So live could actually be this outer thread. I'm just going to put this by the camera's microphone, see if you can just pick up that switching noise that the circuitry is making. I'm not sure if that came through. This bulb glass is cool all around the top here. It's just mildly warm down the bottom here. So I'm just wondering whether that's from the filaments or from the electronics. It's hard to tell. So this item came from eBay. This is the 8 watt warm white version. $5.97. So these LED filament lamps are coming down in price. Free shipping, and this one came from Heaven Stores. And so these are today's Postbag items. Cheerio!